Hello, my name's Devinder Gill. I'm the NCPMS Project Manager for the Lower Tame Flood Risk Management Scheme in Tamworth, West Midlands. This £16 million DEFRA funded scheme comprises 4 individual sections and when complete will deliver reduced flood risk to almost 1,500 properties. Today we're at the Kingsbury section of the scheme. The objective here is to stop flood water from the River Tame flowing into the Birmingham and Paisley Canal and thereby reducing flood risk to almost 1,500 properties downstream. The project team comprises NCPMS as project manager, Hal Crowe as the designer, Jackson Civil Engineering as principal contractor and Bachi Solitanch as the specialist subcontractor. This toolbox talk provides an overview of the Bentonite Slurry wall which has been used on this site to create a cut-off under the flood defence. In particular, the toolbox talk summarises the design considerations that the project team were faced with, explains how the Bentonite Slurry wall is constructed and details the environmental and health and safety risks that had to be managed on site.
Hello, my name is Phil Marsh. I'm the Hal Crowe CH2M Project Manager for the Lower Tame scheme. The design problems we had here at Kingsbury related to building a 1.5 metre high flood wall around some 200-year-old cottages and close to it an old lock structure on the Birmingham Paisley Canal. We were also further constrained by very narrow access routes into the site and also the proximity of water bodies in the Kingsbury Water Park Nature Reserve. The ground investigation for the area came back and indicated the whole area was underlain by highly permeable gravels, which indicated the need for a 4 metre deep cut-off below the concrete wall. We looked at a whole range of options for the cut-off, including plastic and steel sheet piling. We were concerned about these by the footprint of the machine needed to put them in and also the vibration levels which may damage the lock and the lock cottages. We looked at concrete piles which are very expensive and we also looked at concrete trench mix solution, but this was discounted on the grounds that the machine was too large for the site. We started to look at bentonite as a solution to the problem. This appeared to meet all our requirements. It was cheap, easy to install, had a relatively low carbon footprint compared to the other solutions, and most of all it had very low vibration levels during installation, so minimised the risk of damage to the adjacent properties. There was an added health and safety benefit in that the bentonite is easy to trim down to formation level, so it avoids needing to cut steel or break down concrete piles. The one outstanding problem we had to resolve with the bentonite was the potential risk of pollution. We worked hard with Jackson's during the ECI phase and design phase to make sure the mix design was right to avoid bentonite leaching out of the trench while it was curing. We also spent a lot of time investigating services, land drains, septic tank outfalls and other drainage in the area to make sure that there were no pathways to the adjacent water bodies that could cause problems.
Hi, good morning. My name is Dr. Dan Adams of Bachi Solitanch Specialist Geotechnics. I'm here today to talk to you about low permeability slurry walls. Slurry walls are formed using a cementitious slurry comprising cement, bentonite and GGBFS or slag with water. In this particular case we site batch the slurry on site with our high shear colloidal mixers and then pump from our batching up point, which was further down the site here, to the point of excavation. To form the trench we simultaneously excavate the trench with a 360-degree excavator. In this particular case it's about a 13-ton machine, and while simultaneously excavating we keep the trench topped up with the cementitious slurry. Whilst we're digging the trench itself, as I said, we use a 360 excavator. We're excavating through the slurry itself, so all the arisings are coated with the cementitious slurry. One of the key aspects of works like this in such a sensitive environmental area, with the sensitive receptors around us here on this particular site, is control of that slurry and making sure we don't lose it, not only through the walls, side walls of the trench itself, but through spillages and loss, breaks, any burst pipes or anything like that. So that's a really important part of our works, making sure that we control that slurry. The slurry wall typically has a permeability of 1 × 10⁹ meters per second, and that's after 90 days curing. and a strength typically of 100 kPa. That's an unconfined compressive strength of 100 kPa. That's equivalent to a firm to stiff clay in situ when it's cured, and that's after about 28 days. Typically follow-on works in terms of capping and building up the flood defence wall usually takes place once there's a minimum strength of the slurry wall has been achieved, which is typically 7 to 10 days, but that does depend on the prevailing weather conditions and everything like that.
Hello, my name is Paul Wood and I'm the Jackson Civil Engineering Site Manager at Kingsbury on the Lower Tame project. The Bentonite works were located within the Kingsbury Water Park Nature Reserve, and it was imperative that we safeguarded the local environment, paying particular attention to the adjacent lake and canal. Due to the free-flowing nature of Bentonite Slurry, we had to create a level works area and also raise the existing haul road in layers compacted. Debris netting and signage was placed on the Harris fencing adjacent to the Lock Cottage gardens, with sandbags laid out on either side of the works area to prevent grout loss into the lake and gardens and public access into the works. Temporary works design checks were also sought to ensure that the whole road was fit for purpose and to safeguard the plant and labour working in this area. Emergency response plan was put in place should an environmental incident occur. All the operatives were given a method statement and toolbox talk briefing prior to works commencement. These works were closely monitored to ensure that they went in accordance with the agreed method statement. The banksman wore a life vest at all times and also covered the bentonite trench to prevent anyone from falling into the bentonite. An exclusion zone was set up to prevent any unauthorised access, and these works were complete within 2 weeks, including site mobilisation and demobilisation.
In conclusion, bentonite slurry walls provide a cost-effective and practical solution, especially in applications where space and access to the site are limited, and in particular where vibration from traditional street piling is too high. One additional advantage of the process is that the waste arisings from the trench can be reused on site, and in the case of this project, the arisings were used to reinstate the various footpaths and access roads which were disturbed by the construction process. I hope you found this toolbox talk useful, and it encourages project teams to consider bentonite as an option for similar schemes.